numbers will be the first thing we're going to talk about. Complex numbers are easy. One of the easier things we do. A complex number has a standard form that looks like this: A plus BI. The A is what we call the real part. The BI is what we call the imaginary part. There was this really unfortunate naming situation with complex numbers back when they were kind of developing algebra and calculus and things. There were a couple of mathematicians that were, I guess you'd call them pen pals. They would send each other problems to kind of and say, can you work this? Show me how. And then that guy would work those problems, get the answers, and then he would send new problems to the other guy and say, okay, I did those, now can you do these? So it's kind of this challenge thing. They were competing against one another, see who's the best at the mathematics at the time. They didn't have Snapchat or anything like that, so they had a lot of time on their hands to do things like that. So what happened was they both had the abilities to solve quadratics and higher degree polynomials, but there were some of the answers they knew, okay, I know this is a quadratic and it should have two answers because it's got an x squared in the problem. But they couldn't find those numbers on the coordinate plane. They said, I know it's got two answers because every problem that you sent me like this, of this form, had two answers, but I can't find them for this. And so what they started doing was calling, okay, well, this one has two imaginary answers. And then this one had these two answers that we can find, and they called those real. And so that imaginary idea stuck. So they started talking about imaginary numbers. Well, now we kind of progressed and we call them complex numbers, but the imaginary part kind of stuck. It's kind of like one of those things where when you were a little kid, somebody started calling you a nickname and it stuck. You know, it may not be the best name that you ever had, but it's stuck, and that's what everybody calls you. So that's the idea with complex numbers, is that imaginary part. The I came from two guys that were challenging each other in math, and they couldn't find what those answers exactly were, but they knew they existed. So they started calling them imaginary answers, and that's where the I came from for in mathematics. And it's a great great tale of the history of math. But A plus BI, that's the standard form for complex numbers. Standard form for complex numbers. So when you write your answers and it's a complex number as an answer, you need to have it in that order out of that. So let's first define where does the I even come from. So that definition, we'll have four things here that we need to define. The first one is, where does I come from? I comes from the square root of -1. And if we were to square I, that turns into -1. And then I cubed is -I, and I to the fourth power is +1. You need to memorize that little chart. Okay. Memorize that little chart right there. Those four things. Those are things that we're going to use. And when we go to work with complex numbers and add, subtract, and multiply and divide them, those conversions are going to help us simplify. That's what that does. So you need to, as you do these, you'll memorize it automatically probably, but knowing that chart is going to be helpful. What happens here after the I to the fourth power? I to the fifth power starts the cycle back over. I to the fifth power is the same thing as I. I to the sixth power is the same thing as -1. I to the seventh power is -I. I to the eighth power is back to 1. So it just repeats the cycle over and over, the higher degree. And we'll look at some problems where we're actually taking an I to the 50-something power and reducing it as far as we can. So that's, but you need to memorize that chart there. Okay, so where does this come into play? Well, it comes in, we were solving by square roots last week. We never did have a negative come in there, but that can happen when you're solving quadratics. You might work one out and end up having to take the square root of negative 36. And we're going to have to simplify that square root. Well, the number part, you do exactly the same way. So the square root of 36 we know is what? 6. Because it was negative, it gets an I. So the negative on the inside of the square root automatically simplifies out an I. If it's got something a little bit more interesting, like the negative 24 in there, it's not a perfect square. As far as simplifying the 24, we do the same thing that we did last week. We break down 24. If we use 8 and 3, pair of 2's. So there's a 2 that comes outside. Because that 24 was negative, an I also comes out. And then what's left is a 6 on the inside. Okay, so we're getting the